So we've reviewed how to find how many significant figures, and yesterday we talked about exact numbers. So today we're going to talk about doing math with significant figures. Okay? There's two different rules. The rule for how many significant figures you should have in an addition or subtraction problem is different than the rule you should have for a multiplication or a division problem. Okay? So when you are adding or subtracting, you round to the last common digit that occurs furthest to the right in all of your components. Okay? So the example they give is if you take 100 that they are saying has 3 significant figures in it, so we'll put a decimal point just to be clear about that. If you take 100 with 3 significant figures and you add to it 23.643, okay, you will come out with 123.643. But here's the issue. We're assuming zeros here. But did we actually measure zeros here? No, which is why they're not included in the original problem. So we can't report anything with digits out here because this calculation is based on an assumption. Okay? We don't actually know what these digits would actually be because we don't actually know what these digits we're subtracting them from are. So we're going to round to the last number they all have in common, the last place value, which is the 1 spot. So we're going to round to this number, so we look to the right of it, and we're going to round it up to 124. And that would be our final answer. Okay? So when you're adding or subtracting, you look what's the last place value they have in common, round to that place value. If this had a 0 right here on the end of it, then instead of rounding to 124, we would look at the 10 spot and round to that instead, and we'd round to 123.6 instead. Because now we know this value for both of them, so we can report it. What we're trying to do is not report any information we don't know, for sure. Or they will kill you, because that's what we do to liars in chemistry. I almost forgot, before I have you actually round these off, that you need reminders of the rules for rounding. Okay? For the most part, it's very similar to what you're used to. If you're dropping a number that is greater than 5, you're going to round your last digit up. If you're dropping a number that's less than 5, you'll leave it as is. Those are standard rounding practices. The other rules have to do with if you're dropping the number 5, okay? So if you're dropping the number 5 and there's any numbers after that 5 that are not 0, so even if there's a couple zeros and then like an 8, if there's any numbers after that 5 that are greater than 0, then you're going to round up.
So if there's no number after the 5, you round down and you just...
Here's where it gets tricky. If the number after the 5 is 0, or if there's no number, then if the ending number that you're keeping is even, you leave it. If it's odd, you round up.
Okay, that answers my question. I would have got that wrong.
It's in an attempt to keep it like a 50-50 split. Okay, so if you're dropping the 5 and any number after it is greater than 0, round up. If you're dropping the 5 and there's no numbers or zeros after it, then if it's even, you keep it the same. If it's odd, you round up.
If what's even?
The number you're keeping.
Okay.
We'll do some examples. Multiplication and division are different than addition and subtraction. When you are multiplying or dividing with significant figures, your answer should have the same number of significant figures as the least number of significant figures in your calculation numbers. So, an example, we'll do if you do 3.0, which has how many significant figures? 2 significant figures, and you multiply it times 12, 30.60, which has how many significant figures?
4.
4. Good. Okay. You're going to come out with 37.800. Okay? But we don't know that many digits of precision. We own the least number of precision that we have is 2 significant figures. And that's what we're going to report our answer in, because we know we can be precise out to 2 significant figures, but beyond that we can't. So we're going to find that this has, here's where we would have 2 significant figures, and we will round to 38. Okay. Let's run some sample problems on the board. Before we sort of finish up for today, a word of caution about using a calculator. As you know, I'm not going to tell you you can't use a calculator, because I care about your ability to work a problem, not your ability to do long division in your head. So I'm okay with you using a calculator. I just want to caution you that calculators don't factor significant figures in for you. So if you type a whole long string equation into your calculator, you're going to come out with something that's rounded differently and probably incorrectly than what I'm going to have you do. The way you can avoid this and still use a calculator is to break it down into steps, run each of those steps in your calculator, keep as many decimal places as you can, and then round at the end. Right? So if you have like 17 times 34 plus 12 minus 16, do each step of that problem and then take the result and then plug that back into your calculator. Don't just type the whole long string in. Does that make sense? Because it's going to do like rounding in the middle for you that you don't want it to do for you. And then you'll come out with an answer that's different. You can ask my physics kids. They're running into that already.